Ever wondered how your phone turns your voice into text, or how subtitles pop up on your favorite shows? It's all thanks to automatic speech recognition, or ASR. But how does it actually work, and why has it gotten so much better over the years? Let's break down the science behind the magic. First, early ASR systems relied on basic statistical models, like the ones from the 90s that tried to map sounds to words using probabilities. But these were limited. Think of them as trying to solve a puzzle with missing pieces. Then came deep learning, a game changer. Papers like the 2018 study on open-source ASR tools showed how researchers could build powerful transcription systems using publicly available code, making the tech more accessible and collaborative. But speech isn't just about sounds, it's about context. That's where models like BERT come in. Originally designed for text, BERT's ability to understand language in both directions, forward and backward, revolutionized how ASR systems correct errors. For example, a 2022 paper used BERT to refine transcriptions, catching mistakes that traditional methods might miss. It's like having a grammar checker for speech. And what about videos? Modern systems don't just listen, they watch. The 2020 violin dataset, for instance, trained models to connect audio and visual cues, making subtitling more accurate. Imagine a video where the AI notices a character's lips moving and matches it to the right words, even in noisy environments. Then there's the rise of large language models. Papers from 2020 and beyond, like the one on GPT-like systems, showed these models could learn from just a few examples. This means ASR systems can adapt to new accents, slang, or even rare languages without needing massive data sets. It's like teaching a child to recognize a new word. But here's the breakthrough. Researchers are now combining audio and video to fix ASR errors. Let's dive into how this works. Traditional ASR relies only on audio, but that's like trying to understand a joke from a single sentence. Enter video-guided post-correction, a method that uses visual context to refine transcripts. Here's the science. A standard ASR model first generates a rough transcript, like a first draft. Then a powerful AI called VLMM, Visual Language Multimodal Model, analyzes the video. It answers two key questions. What TV show is this? And what's happening in this scene? For example, if the video shows a character in a lab coat, the model infers the setting is a science show, correcting a misheard word like test tube to lab. Or if the scene cuts to a famous character, it flags a name error, like Joey Tribbyany being misrecognized as Joey Tribbyany. This visual context is then fed to a large language model, a kind of AI that's great at refining text. Together, these tools act like a team of editors. The video model spots clues, and the language model uses them to polish the transcript. The results? In tests, this approach reduced errors by over 20% on some TV show datasets. For example, one model's error rate dropped from 45.5% to 35.4%, a huge improvement. And it's not just about fixing obvious mistakes. The method helps ASR systems grasp subtle nuances, like sarcasm or cultural references, by linking audio to visual cues. Why does this matter? Better ASR means clearer subtitles, smarter voice assistants, and more accurate transcriptions for everything from lectures to podcasts. It's a step toward making technology more human, literally seeing the bigger picture. Next time you watch a video, remember, behind the scenes, AI is working hard to make sure every word is right. Thanks for watching, stay curious, and let's keep exploring the future of tech together.